Section 4 video on applying our scale factor to surface area and volumes. Now, here we're just being asked to come up with a scale factor. They give us an order, which matters, left to right. So everything is left to right. And then find the ratios of surface area and volume. Now we found out in previous videos that if we knew the original scale factor, we can find the other two. So since they say left to right, we're going to find our scale factor. And we're going to go, I want to match up my corresponding sides. I have two sides to choose from. I'm going to choose the base of 36 and 72. So 36, again, left to right, over 72. They ask for a scale factor, so we have to reduce. If I reduce the scale factor, I get 1/2. This is the scale factor. Now if I square that, 1/2 squared is 1 squared, which is 1, 2 squared, which is 4. I get the ratio of surface areas. Remember, area is squared. If I choose to, instead of square it, cube it, 1 cubed is 1, and 2 cubed is 8. This is the ratio of volumes. And again, the units for that is cubed, units for area is squared, all coming from our scale factor of 1/2. So the next one, left to right again, I'll just choose these two. So 21 over 70, left to right, reduces to 3/10. This is the scale factor. To find the ratio of areas, I will square each of those and get 9/100. That's the ratio of surface areas. If I choose to instead cube each of them, because volume is cubed, so that's why I cube it, I get 27. 3 times 3 times 3 is 27. And 10 times 10 times 10 is 1,000. This is the ratio of volumes. We will need to be able to get this information in order to solve problems. So if you look at the next question, the next two here, we have the application of this. They give us a scale factor of 1 to 9. They give us the surface area of and the volume of the smaller figure. Find the surface area and volume of the larger. So if you look at this right here, this is the smaller, this is the larger. So they went small to big. So how do I find it? Well, if I want to make a ratio for surface area, I need to make sure I'm using the proper ratio. I can't use scale factor because that's a ratio of sides and perimeter. So I need to do a squaring of both terms, which is 1 over 81. This is a ratio of surface areas. So I go 1 over 81 equals, now 3 is the surface area of the smaller figure. Okay? Because they told us that they gave us the smaller one. So I go 3 over an unknown. If I cross multiply, I get x equals, because this is what we're doing, I get x equal to 243. The units are given, it's meters squared. Or in this case, yep, meter squared. Now volume, I have to find the ratio of volumes. So I take my 1/9 and I do something different. I take my 1/9 and I cube each one. So I get 1 cubed is 1, 9 cubed is 729. And that is what I will use. I'm given the smaller shape, and I don't know the larger. When I cross multiply, I will get 16,000, 767 meters cubed. Next one, we have scale factor of 7 to 8. So a scale factor of 7/8. Now right away, I'm going to do something. I'm going to square each one and get 49 over 64, which is a ratio of surface areas. And I'm also going to cube each one. And 7 cubed is 343, or excuse me, 343. 8 cubed is 512. And this is a ratio of volumes. And I have my information now. So if I do a ratio of, if I want to find out surface area of the larger shape, I take the ratio of areas, which is 49 over 64, and I put 882 on top because that's the smaller shape, and we get x equal to, after we cross multiply, we get x equal to 1,152 yards squared. All right, so we finish it. By taking the ratio of volumes, which is 343 over 512, and saying it equal to 4,802 over the unknown bigger shape. Cross multiplication of this gives us 7,168 yards cubed. So if we know the scale factor, we can find the ratio of surface areas and volumes respectively, and then from that we can make our proportions to solve. And this ends section 4, open questions.